Hi guys, my name is Ryan Baziaco, and today I'm going to take a look at this algebra problem that I saw. So we need to find all pairs of a and b that satisfy the equation a cubed plus 2ab equals 2013 when a and b are positive integers. First thing I want to look at here, and I think you should always recognize, is this a cubed. Now this 2ab, if b is 1, then this value isn't going to be that great, but this a cubed can make up a lot of substance. And I think right off the bat here, we can determine an upper bound for what a has to be. Well, we know a has to be bigger than 0, because it's a positive integer, but we can also set a maximum. So if you go into your calculator, try 10 cubed. Well, that's just going to give you 1,000. What about something like 11 cubed? 11 cubed, you go calculator 1331. What about 12 cubed? Well, if you were to go 12 cubed, you get 1728. Now try 13 cubed. Well, when you go 13 cubed, you're going to notice something. You're going to notice that this number is way bigger than 2013. And since we know that 2ab is going to be positive because a and b are positive integers, that a just can't possibly be 13 or anything bigger. So right now I'm just going to set some restrictions on a. We know that a has to be greater or equal to 1, but it also has to be less than or equal to 12. Now this is a good start. Now what speaks out to me is that both terms on the left have an a in them. Let's manipulate that side a little bit and see what we can do. I actually want to factor out an a here. If I factor out an a from each term, I get the a times a squared plus 2b is equal to 2013. Now let's just move the a over. A squared plus 2b is equal to 2013 over a. Now, this 2013 over a, we can see that it has to be an integer. Because if a and b are integers, then a squared plus 2b is going to be an integer, which means that 2013 over a must also be an integer. That's huge because that's saying that if you take 2013 and divide it by a, it must be an integer. Now if you go into your calculator, if you were to go 2013 over 2, it's going to give you some decimal. 2013 over 4, some decimal. And it's a rule, if you take any odd number and divide it by an even number, you're going to get a decimal. So that right there says that a cannot be equal to an even number, because if it were, the right side would be a decimal value. So that right there just leaves a to one of 6 values. 1, 3, 5, 7, 9, and 11. From here, we can also look at the fact that 2013 over a must be an integer. And we can take these 6 numbers and take 2013 and divide them. And if they give an integer value, then it may be a solution. If they don't give an integer value, well, then we know that we can cross it out. 2013 over 1, obviously that's an integer. If we go 2013 over 3, I believe that is an integer. Yes, it's 671. 2013 over 5, it does not. If we go 2013 over 7, it also does not. 2013 over 9, also does not. And 2013 over 11 does. So these are our A values. A has 3 values that it can be. As long as we plug these 3 A values into the equation and get an integer, positive integer for B, then we know that there can only be 3 pairs A, B that work. And they must include 1, 3, and 11. So let's start by plugging in if A is equal to 1. Well, if A is equal to 1, sorry, I just gotta get my pencil tool. If A is equal to 1, then the equation becomes 1 cubed is just 1, plus 2b is equal to 2013. 2b is equal to 2012. And b is going to be equal to 1006. So we know that this must be a correct pair. Now let's try when A is 3. Well, 3 cubed is just 27. 2 times 3 is 6. That's a B. Subtract 27 from both sides. We get that 6b is equal to 1986. Divide both sides by b, or divide both sides by 6, sorry. And we get that b is equal to 1986 over 6, which is just 331. So we know that also must be a correct pair. And if you want to, check your work, you kind of any time, if you plug these pairs back into the equation and you see that they're true, well, then you know that you're right. For the last case, if A is 11, well, we already did that calculation earlier, I believe. 11 cubed is 1331. 2 times 11 is 22. Now I can subtract 1331 from both sides. If we go 2013 minus 1331, 682. 22b is equal to 682. And lastly, divide both sides by 22. B is equal to 31. And 11, 31 is another solution. We can write out a final statement. Three pairs first one was what? 1, 1006, right? Yeah. Second pair, 3, 331. Our last pair being 11, 31. And that is all for this video. I hope you guys enjoy.